Hello again to all subscribers and listeners of this channel. This video is Why Evolution is Bullshit Part 3. Human Evolution numbers 1 through 3. And I'll say it again. Evolution is a hypothesis posing as a theory that people believe is a fact. To start off, I want to let everyone know that we are now moving on to part 3 of the series. And in part 3, there will be a greater focus on why evolution has not been proven to occur in humans, Homo sapiens, man, humanity, mankind, etc. There's no actual evidence that we came from a common ape ancestor as far as I can see. A lot of it's just philosophy and conjecture. There's no evidence that showing that our species came from the common ape ancestor, and things like the fossil record, the anatomical inconsistencies, the morphology differences, the lack of transitionals, etc., are all lacking any evidence of this progression of the Homo sapiens sapien from some ape-like being that supposedly existed millions upon millions of years ago. So without any further ado, let's get into the reasons why human beings have not been scientifically shown to have actually evolved from a common ape ancestor, and why the evolutionary theory of humanity is at the very least unproven. So let's go. Why Evolution is Bullshit Part 3. Human evolution? 1. There are no transitionals. This goes back to the common ancestor fallacy that I spoke about in earlier parts. Here's what we have. We have found fossils of ape-like organisms from supposedly millions of years ago. We do have a species of organism that's alive today, Homo sapiens sapien. But we also absolutely have no gradual transition from one to the other. And then you tell me that there was a slow but steady graduation from one form to the other. But again, you have no actual proof of that. There's no actual transitionals. So that statement is very incomplete. Here are the reasons why. 1A. The morphological differences between today's apes and human beings are too great. There are far too many morphological differences between the great apes and human beings for there to be an account of how they all somehow evolved from a common ape ancestor. There's too little information out there. The fossil record has too few specimens to break down or to show us that showed how they became these 4 different species. For instance, the apes, pretty much all of them, the chimpanzee, the gorilla, the orangutan, they all have, in comparison to humans, these characteristics. Smaller craniums, darker colored eyes, larger and stronger jaws, longer and narrower pelvises, the ability to knuckle walk, disproportionately long arms, and disproportionately or proportionally short legs. A much lower amount of gray matter in the brain of the chimpanzee, gorilla, and the orangutan, whereas human beings have a much larger amount of gray matter in our brain and in our nervous system. The great apes all average a body fat percentage much below 10%, whereas most humans have a body fat percentage between 15 to 40%. So even a slim or skinny person has a body fat percentage that might be almost double what a chimpanzee or a gorilla has. It's very interesting. And the fossil record doesn't seem to account for all of these morphological differences. As in, we're seeing a lot of ancient ape-like creatures or ancient hominids have a body structure like an ape, or they have a body structure more like a human. But there's not enough of a transition between the two. They all just seem to be distinct different species. 1B, the line that should exist coming from the common ape ancestor. If there indeed was a common ape ancestor, here's what we should be seeing. We should be seeing a gradual transition from that ape ancestor to the chimpanzee. We should be seeing a gradual transition from the ape ancestor to the gorilla. We should be seeing a gradual transition of that ape ancestor to the orangutan that somehow crossed the ocean and went over to South Asian islands. And a gradual transition from the common ape ancestor to the modern Homo sapiens sapien, aka modern humans. 1C, the number of transitionals we have to find. So ultimately, we need 4 different branches of evolution when it comes to the apes. One branch from the common ape ancestor to the chimpanzee. Same thing with the orangutan, the gorilla, and the Homo sapien. Yet the fossil record doesn't seem to show us this. Instead, they show not any real transitionals at all. They appear to be only somewhat similar species stitched together on an imaginary graph of a tree or a bush representing an evolutionary line. Number 2, if there are transitionals, this is how many that there should be and how many we need to find. And this is what they should have in their physical structure. 2A, this is how many species of ancient ape hominid has been discovered so far. And according to most sites and most references, books, encyclopedias, science journals, etc., the number of hominid type species in the fossil record is anywhere from about 18 to maybe up to about 30 different species, which is a really small number considering what they're saying happened to the Homo sapiens sapien. That is way too few, as far as I'm concerned. 2B. Now, as far as I can see, this is how many there should be for the entire record of all the beings that supposedly descended from the common ape ancestor. When considering the huge range of physiological differences there are between apes and modern humans. Sorry if you hear that in the background, but there's fireworks going on. But let me get back to it. There should be far more than just 18 to 30 species. There should probably be more than 100 different types of hominid species or ape-like species between the ancient ape ancestor and all the modern apes that are alive today and Homo sapiens sapiens. Why? Because the fossil record we have doesn't come close to accounting for the morphological differences that developed within our species as opposed to others. What are these differences? Again, refer to 1A for a list. What should the fossil record be showing us? It should be showing us a list of changes gradually moving through each and every subspecies. There should be dozens of intermediaries between the common ancestor and the chimpanzee. And this should repeat itself for the orangutans, the gorillas, and the humans. So when you look at that, by looking at each species difference between itself, the next species over, and the supposed common ancestor, one can easily argue that we need 50 or more species between each of these current apes and the common ancestor. So when you look at the totality, that's easily 200 or maybe even as few as 175 more that we need to find in the fossil record. Again, we have a max of maybe 30. We look at the morphological differences as in what led up to the chimpanzee and then what led up to the Homo sapien. Those are 2 different lines of supposed evolution. There needs to be like 50 for each one. You have less than 30 only for humans. Again, way too small, way too low of a number for the transitional species. It should be way greater than that when you consider how morphologically different the apes are from each other, how they're different from human beings, and how all 4 of these, Homo sapien, gorilla, orangutan, and chimpanzee, how different they are from the common ape ancestor. None of this makes sense for the fossil record to be so small and have so few specimens. 2C, and this is what we should see in their anatomy throughout the study of their fossils. We need to see a very gradual increase in skull size And unfortunately, the gaps in skull size seem to be in the hundreds of cubic centimeters difference between one species and the next. In fact, I'm going to put the list in the description so you can see on what I'm talking about. If you look at a list linked in the description carefully, the cranial capacity does not gradually increase. The increases they're jumping all over the place. But let me get back into it. First, it's kind of all over the place, like I said. And secondly, the increases can be seen in increments of 100 cc or more, when they should be only a few dozen cc difference or less in more of the individual species, or in the end they should have the smaller increments. So the increments are like 100, 150 between each one. They should be like 12 or 20 for each one. But we're getting these huge jumps in cranial capacity that cannot be explained in the fossil record. It doesn't make sense. Also, we should have twofold. We should have smaller jumps in the cranial capacity, and we should also have a much larger number of species in the fossil record. So smaller increases incrementally in the cranial capacity among more individuals, more species within the fossil record. Instead, we're getting only a small portion of species in the fossil record, which with gigantic jumps in the brain size, gigantic leaps in the cranial size. Doesn't make sense. We also need a gradual increase in the pelvis size that matches perfectly with the increase in skull size. I'm going to get into that later in number 3. We also need a steady transition from knuckle walking to upright walking. We need a steady transition going from a C-shaped spine to an S-shaped spine. We need a gradual shrinkage of the jaws and the teeth. We need a gradual increase in overall size and height. It's very odd, because again, you're going to see this on the list when I link in the description. It's very odd that Homo naledi is supposed to be a much more recent hominid type species or hominid specimen, yet it's shorter and smaller and has a smaller brain, and it physically seems less mature than Homo erectus, who's supposed to be much older and much more distant hominid species. So again, the evolution was supposed to push everything closer and closer to being more hominid-like, taller, larger brain, more advanced, more gracile, more, what's the word I'm looking for? A more refined, svelte look. Yet Naledi seems more regressive than Erectus, despite the fact Homo erectus is supposed to be older. So someone explain that one to me. And again, these changes should be occurring among a much larger number of species than what we found. And they all should be very, very gradual. We're seeing leaps in physiological changes in these very small sample of hominid species. Something doesn't add up. Number 3. The Homo sapiens skull did not increase on its own, and it could not have increased the way they tell us it did. It had to already have been large from day one. Now, the theory goes, Homo erectus and other similar species started eating more protein from, eating meat, which increased the brain size. Never mind, protein doesn't increase your bones, does it? Yet the skull, the more important object, is actually the skull, not the brain. But the skull had to increase also. In fact, I would argue it's more important for the skull to increase, not just the brain. But that's beside the point. Which means they also had to ingest and utilize more calcium. But there's a problem. The Homo sapien cranium cannot just simply get larger on its own. The pelvis of the female has to widen along with the increasing cranial size in order for the mother to give birth to a larger brained offspring. And when you watch the video, you're going to see the difference in the pelvic structure of different hominid species. Again, something's not adding up. If we all have a common ancestor with the apes, someone needs to show how the common ancestor eventually evolved to become the chimpanzee, which retained a narrow pelvis, and then show another line of how that common ancestor slowly became the Homo sapiens sapien with a much shorter and wider pelvis. They never show that. They just showed these randomly different pelvises of both the existing apes and the prehistoric hominids. But let me give you an example. For example, imagine that you're in a car and you're traveling at exactly 75 miles per hour. The car is going 24 hours a day on a nonstop trip from New York to Los Angeles, from New York City to Los Angeles, California. And there's another car on the same route traveling maybe not even up to a centimeter away from you, but they're traveling right next to you. So you couldn't fit your finger between the two cars. They're right up against each other. Here's things you need to break down. Major things to mention. That other car is traveling in exactly the same direction as you. It's traveling at exactly the same speed. And it's literally less than 1 centimeter of space between the two cars sideways. So the two cars are right up against each other. They have got to stay exactly at the same speed, same distance, same momentum, same velocity, same everything. They have to turn, accelerate, decelerate, stay in exactly the same way, same distance for the entirety of the entire trip for each other at all times. If any wrong move, literally like a couple millimeters of a wrong move is made by either of the cars, both cars are going to be decimated. Both drivers are going to be dead. There's going to be nothing but absolute destruction unless these two cars stay in exact tandem with each other. That is how precise the cranial growth has to be. If the cranium of the hominid grows in size, the pelvis of the female has to grow in tandem with it. If either one grows too quickly or too slowly, that literally could be the end of the entire species. Since they couldn't give birth, every baby would be stillborn, or the mother would die from blood loss because there'd be too much trauma on a pelvis that's too small to give birth. So, the brain size increased because of protein. It's like, no. The skull size increased because of calcium. I don't know how much protein plays in the role in making the skull bigger, but the skull got bigger, not just the soft brain tissue. The pelvis also got bigger. And they don't have an explanation for how the pelvises not only grew, but grew in a way that is perfectly in line with the skull growth. So along with the cranial expansion, you have to have the pelvic expansion at exactly the same rate throughout every generation of the species for multiple generations, through the vast majority of the generation in each generation, for millions of years without relatively a hitch. Now again, someone please explain to me how increasing protein intake somehow widens the female pelvis to stay exactly in line with the increasingly large cranium of the baby. In other words, if the average cranium increased by 5%, the pelvic opening of the female had to increase by 4.999 to 5.111%. Very, very narrow increasing. The increase had stayed exactly incredibly that tight range with relatively no room for error. And if it hadn't, I'll say it again, the mother, the child, or both would be dead. And generation after generation would result in too many stillborns or dead mothers, aka the species runs the risk of going extinct. So that cranium and pelvis were pretty much in line with each other from day one. Evolution does not explain that. Your protein intake for the larger brain, it does not explain that. Sorry. There needs to be a better explanation. The brain did not just get larger. The skull and pelvis did this at the same time, and we don't know how. But I'm going to end it right there. I don't want this to go too long. So that's all for now. Until the next part in the series, please like, subscribe, share, and donate to support this channel. Check out my Patreon. You guys have a nice day. I'm out. Peace.